So welcome back everyone to the YouTube platform of IMS Gate Academy. Myself Prateek Mishra, and we are conducting this foundation series to give you an idea about environmental engineering, the basic concepts of environmental engineering that will help you to read heavy concepts of environment. In the previous sessions, I have given you the clear idea about what all things in environment are the important areas, like it starts from water demand, population forecasting, then we have seen water quality parameters, then some treatment of water we have seen. After that, we have read about the wastewater quality parameters, especially BOD, and then we have seen the biological treatment through trickling filter and activated sludge process. I hope you are following all the previous sessions that I have conducted. Today, the topic of discussion is air pollution. My dear, it is one of the easiest topic from where we are regularly getting the questions. Air pollution has some critical areas which has to be read before reading into the pure concepts of air pollution. So today we will going to see all those things which are a kind of prerequisites of completing the topic of air pollution. So you just stay tuned till the last of this video and you will get all the basics which are required for completing this air pollution. Before starting this session, my dear, I would like to make few announcements. The first announcement is regarding our Telegram group. The link is given in the description box. If you want to join our Telegram group, you can join by using that link. We regularly provide the lecture PDFs, YouTube sessions, details, the planning for YouTube. Then we regularly post the quiz in our Telegram group. So you can enjoy those regular quizzes through this Telegram group. We also update you on the regular job notifications that are coming for the government jobs especially, and we regularly conduct the seminars and webinars for which again we post the link in the Telegram group. So link of the Telegram group is given in the description box. You can join that link. Next, we at IMS Gate Academy, my dear, we provide you with 4 different types of program where we provide 800 hours of live teaching with interaction and doubt solving. We provide you with online program, offline program, hybrid program and the self-learning program. Along with these programs, we provide you with a theory and exercise book containing more than 4,000 practice questions, well versed in level 1, level 2 and level 3, so that even the student has a clear-cut idea what is their preparation level. We provide you with an exclusive GATE question bank containing 34 years of GATE question, where we have provided the detailed solution, alternate solution, video solution along with key points in chapter overview. All the questions that are asked in GATE examination till now have been included in this GATE question bank. Again, question may not be repeated in GATE, but surely there are certain concepts which are regularly repeated in the GATE examination. So you can practice all those concepts using this GATE question bank. We provide you with 12 personalized one-to-one mentoring sessions. These are personal guidance sessions to help you stay motivated in this hectic journey, to have your preparation well planned so that you can maximize your efficiency of preparation. We provide you with India's largest test series containing 130 plus tests, starting from the chapter test, subject test, multiple subject test, advanced subject test and the full length mock test. And for the full length mock test, we provide you with solution of the challenging question. If you want to book a free counseling session, the link is provided in the description box. You can book your slot as per your convenience. And if you want to speak to a senior student advisory team, senior education advisory team, you can just contact to these numbers and you can speak to them, right? So with these words, I would like to start my today's session of air pollution. So my today's session will be like more generic session rather being more technical session. Reason is air pollution is a generic topic. Okay. If I ask you one simple question, CO2 is a pollutant. Is CO2 a pollutant? Can anybody answer me on this? Is CO2 a pollutant? If I just give you one gas like carbon dioxide and ask you simply, CO2 is a pollutant. So what will be your answer? What can you say on this? What can you say on this? Is CO2 a pollutant? CO2 is released by all the plants, right? CO2 is released, absorbed by all the plants, and at nights it is released by all the plants. All the human beings, all the living species, they release CO2. So can I say CO2 is a pollutant? Can I say it? CO2 is a pollutant. Carbon dioxide is a pollutant. Can we say it directly? Okay, so for this you need to understand some basic concept of air pollution. How we call any gas as a pollutant and what are the factors that affect those pollutants. So first of all, my dear, what happens is, this is our earth. This is our earth, right? Due to the different industrial activity, CO2 is released in the atmosphere. Due to different industrial activity, CO2 is released in the atmosphere. This is our earth, right? Due to different industrial activity, CO2 is released in the atmosphere. This released CO2 forms a layer around the earth like this. This released CO2 forms a layer around the earth like this. This is the layer of CO2 which is formed. The released CO2 forms a layer around earth like this, okay? Please understand this very carefully. We will be dealing with a very, very important concept. This is the layer of CO2. Okay, this is the layer of CO2 which is formed around the earth. Now see what happens. We have a beautiful sun here from where we are getting all the lights. This is our beautiful sun from where we are getting all the lights. So different kind of radiations falls over the surface of the earth like this. Different radiations falls over the surface of the earth like this, right? After hitting the surface of the earth, these radiations from the sun is reflected back. This is how these radiations are reflected back into the atmosphere. Means whatever radiations are falling from the sun, they are reflected back by the surface of the earth. Now what happens is, this CO2 layer in the atmosphere of the earth, they reflect back some radiations. They reflect back these reflected radiations. They reflect back these reflected radiations. They reflect back these reflected radiations. Okay. They reflect back these reflected radiations. Okay. These are my reflected radiations by the earth's surface. These are the re-reflected radiations by this CO2 layer. Please understand this very carefully. We are discussing one of the very, very important problem that is globally seen. I hope you have also guessed the name of it. So this is my CO2 layer. This is my CO2 layer. And how this CO2 is released? This CO2 is released by different industrial activity in the earth. And this CO2 released in the atmosphere forms a CO2 layer around the earth. These are the radiations coming from the sun. So these are the radiations coming from the sun. Direct radiations which are coming from the sun. So after these radiations hit the surface of the earth, they are reflected back into the atmosphere. So these are my reflected radiations. These are my reflected radiations. Now what happens is, this CO2 layer re-reflect back some portion of this reflected radiation. This CO2 layer re-reflect, this is re-reflected radiations. Re-reflected radiations by CO2 layer. These are re-reflected radiations by CO2 layer. The temperature that you have over the earth nowadays, due to which life is possible on the earth is because of these re-reflected radiations. Because if all the radiations which are hitting the surface of the earth are reflected back, then the temperature of the earth would have been very less and there would have been no life possible on the surface of the earth. But due to this CO2 layer, since some portion of this reflected radiations are reflected back, these re-reflected radiations help to develop the ambient temperature of the earth, which is responsible for the life in earth. Okay. So right now we are observing that this CO2 is a lifesaver. If there would have been no CO2 layer, then there would have been no life on the surface of the earth. Okay. So now you call CO2 as a pollutant. Now you call this CO2 as a pollutant. Again my question is same. Will you still call this CO2 as a pollutant? Will you still call this CO2 as a pollutant? Will you still call this CO2 as a pollutant? So I am writing this. Re-reflected radiations by CO2 layer are responsible for maintaining ambient temperature of the earth. Ambient temperature of the earth. Now see, till here there was no problem. When there was some nominal thickness of the CO2 layer and some portion of this reflected radiations are re-reflected back, till then there was no problem. Now what happened is, due to huge industrial development, we have started releasing more and more amount of carbon dioxide into the atmosphere. And due to this more release of carbon dioxide, this thickness of CO2 layer has grown over the years. It has grown over the years. The thickness of this CO2 layer has grown over the years like this. The thickness of this CO2 layer has grown over the years like this. The thickness of this CO2 layer has grown over the years like this. This is the increased thickness of the CO2 layer. The thickness of this CO2 layer has grown over the years like this. The thickness of this CO2 layer has grown over the years like this. Due to this increased thickness, now this CO2 layer is reflecting more amount of reflected radiations. This CO2 layer is now reflecting more amount of radiations back to the surface of the earth. Now this CO2 layer is reflecting more amount of radiations back to the surface of the earth. This CO2 layer is reflecting more amount of radiations back to the surface of the earth like this. Now it is reflecting more amount of radiations back to the surface of the earth like this. It is re-reflecting more amount of CO2. This CO2 layer is now re-reflecting more amount of this reflected radiation. Due to the increase in this re-reflected radiation by the CO2 layer, the temperature of the earth is increasing over the year. And that problem is termed as global warming. Global warming is a very serious issue nowadays, right? Global warming is causing the melting of the glaciers, which is leading to the increase in mean sea level. Global warming has also affected the climatic conditions, right? Nowadays, we don't have the fixed pattern of seasons. Earlier, we used to have proper rains in the month of June, July, August. Then we used to have proper winters in the month of November, December and January. But nowadays, this cycle is affected. You see so much amount of heat. Heat waves are going on in our country right now, especially in the northern belt of the country. Huge heat waves are there. This change in climate is because of global warming. Global warming is one of the very alarming situation for the life in earth. Okay. Because if you don't have the glaciers, okay, your quantity of fresh water, drinking water will reduce over the years. And if more and more water is means released into the sea, eventually the mean sea level will rise and it leads to the sinking of so many cities. We are regularly getting those updates on sinking of the cities, water level being rise, okay. And this is all caused because of global warming. So when CO2 was present in somewhat amount of thickness, it is not causing any problem. But this excess release of CO2 in the atmosphere has increased the thickness of the CO2 layer, due to which more amount of re-reflected radiations are coming back to the earth. And since more amount of free reflected radiations are coming back to the earth, it is lead to the increase in rise of ambient temperature of the earth. It has lead to the rise in ambient temperature of the earth. And that has caused the problem of global warming. So you can write this down. Due to the increased thickness of CO2 layer, due to the increased thickness of CO2 layer in the atmosphere, more due to the increased thickness of the CO2 layer in the atmosphere, the amount of re-reflected radiations, have been increased, which led to increase of ambient temperature of the earth. Causing the global phenomena of global warming. So if anybody asks you, right, whether CO2 is a pollutant or not. So when CO2 was present in limited quantity, it was not a pollutant. When the quantity of CO2 have been increased and it is there for such a duration that it starts affecting life over the earth, then that same CO2 will be considered as a pollutant, and that is a general definition of an air pollutant. Which pollutant or which substance of air is called as a pollutant? So that element of air which is present in such a concentration and for such a duration of time that it starts affecting the life on earth or life in troposphere is termed as the air pollutant. So the basic definition of air pollutant is if a component of air is present in such a concentration for such duration of time that it starts affecting life in troposphere. Why I am writing troposphere? I am just explaining you. That starts affecting life in troposphere is termed as a air pollutant. So the general definition of air pollutant is that component of air which is present in such a duration and in such a concentration that it starts affecting life on earth, then that is termed as the air pollutant. Okay. Now there are some basic things, some basic definition that you read previously in your school or other places, right? So you need to know about this. So this is my earth, this is my beautiful earth like this. Okay, this is my beautiful earth like this. So this part of land where all the animals reside, is known as lithosphere. Part of land is known as lithosphere. Part of land is known as lithosphere. Now, apart from this land, you have these water bodies. So, these water bodies are termed as biosphere. So, these water bodies are termed as biosphere. Now, this lithosphere, biosphere and the troposphere. This is hydrosphere, not biosphere. Why I am writing this? This is hydrosphere, not biosphere. This is hydrosphere. Portion of water is known as hydrosphere. Then this lithosphere, hydrosphere and this troposphere combinedly, the closest layer of atmosphere from the earth is troposphere. Lithosphere, hydrosphere and troposphere combinedly is known as biosphere. So you have lithosphere, plus hydrosphere plus troposphere these are combinedly known as biosphere. So either the life will be present over land, it will be present over underwater, or it will be present in air like birds. So in this definition you can change this. So it starts affecting life in troposphere I have written, you can write down biosphere. So it starts affecting life in biosphere, that will be the correct term. It starts affecting life in biosphere. So this will be the correct term. It starts affecting life in biosphere, that is either on land or on water or in the air. So that is termed as your air pollution, air pollutant. Okay. So this is one thing. Now if we talk about the different layers of atmosphere, so they can be classified like this. Next is different layers of atmosphere. So this is my Earth's surface. This is my Earth's surface. Above Earth's surface, the closest layer that I have is termed as troposphere. This closest layer that I have is termed as troposphere. Above troposphere, you have stratosphere. Above stratosphere, you have mesosphere. This is mesosphere. And above mesosphere, you have exosphere. And all these four layers are termed as the layers of atmosphere. These are your different layers of atmosphere. These four layers are your different layers of atmosphere. So this is your Earth's surface. Now this year in GATE examination, we got a question regarding different types of pollutants. Okay. So the next topic of discussion is types of pollutants, types of air pollutants. Types of air pollutants. So basically air pollutants are categorized into two types. First one is known as primary pollutants. So basically primary pollutants or primary air pollutants are those pollutants which are released directly from the source. Like when you ride a vehicle, carbon monoxide is directly released from the exhaust, carbon dioxide is directly released from the exhaust, oxides of sulfur are released, oxides of nitrogen are released from the different chimneys of the industry. We are seeing regular this oxides of sulfurs and oxides of nitrogen being released into the atmosphere. So those air pollutants which are directly released from the source are classified as primary air pollutants. So primary air pollutants are those air pollutants which are directly released from the source. They are directly released from the source. They are directly released from the source. They are directly released from the source. Example of primary air pollutants are carbon monoxide, then you have carbon dioxide, then you have oxides of sulfur. So these are oxides of sulfur. Like SO2, SO3, SO4, like that. Then you have oxides of nitrogen. So these are some of the primary examples of primary air pollutants. Oxides of nitrogen. So these are some of the primary examples, right? Then you have the second type of air pollutant which are known as secondary air pollutants. So secondary air pollutants are those air pollutants which are formed due to the combination of two or more primary air pollutants. So secondary air pollutants are classified as those air pollutants. So second type of air pollutants are secondary air pollutants. Or secondary pollutants. Secondary pollutants are formed by the combination of two or more primary air pollutants. They are formed by the combination of two or more primary air pollutants. Two or more primary air pollutants. Certain example of secondary air pollutants are ozone. You have ozone as an example. Ozone is an example of secondary air pollutant. Now there is one very interesting thing about ozone. Ozone, if it is present in the stratosphere, right, it acts as a shield against UV radiation. Whatever radiations that are coming from the sun, this ozone layer actually shields the UV radiation. But if the same ozone is present around the surface of the earth, means close to the surface of the earth where we are living, the same ozone is considered as a pollutant. Reason is, ozone is a very strong oxidizing agent. So if it comes in contact with any metal, it will going to corrode the metal like anything. It will going to oxidize the metal like anything. It's a very, very strong oxidizing agent. So ozone, if it is present near us, near the surface of the earth, it is considered as a pollutant. And if the same ozone is present in the stratosphere, then the same ozone acts as a shield against UV radiations. So ozone is the first secondary pollutant. Then you have acid rains. So acid rains are basically caused by sulfuric acid or nitric acid. Now how these acids are formed in the atmosphere? So basically what happens is, oxides of sulfur combines with the water vapor present in the atmosphere, and this reaction happens in the presence of sunlight. So it's a photochemical reaction. Okay, oxides of sulfur reacts with the water vapor present in the atmosphere in the presence of sunlight to form sulfuric acid, which is sulfuric acid, and this is taking place in the presence of sunlight, and this sulfuric acid causes the acid rain. Similarly, there are oxides of nitrogen, NOx. Again, it combines with water vapor present in the atmosphere to form HNO3, nitric acid. And these two acids are primarily responsible for causing the acid rain. Both the reactions are photochemical reaction. This H2O is the water vapor present in the atmosphere, and this reaction takes place in the presence of sunlight. So I'll write here both of them are photochemical reactions. Both of them are photochemical reactions, right? So these are two types of pollutant, primary air pollutants and secondary air pollutants. The only difference between primary and secondary air pollutants is primary air pollutants are directly released from the source, whereas secondary air pollutant is formed by the combination of one or more primary air pollutants. Okay. After this, the next topic of discussion is sources of air pollutants or sources of air pollution. Sources of air pollution. The first source of air pollution is known as the point source. For example, all of you have this chimney at your house, right? And from this chimney, whatever smoke from the kitchen is produced, it is taken into the atmosphere. So that is treated as a point source. So all the chimneys that you see are an example of the point source. All the chimneys that you see around are the example of the point source. All the chimneys that you see are the example of point source. This is my chimney, and from the chimney smoke is coming out like this, right? So all these chimneys from where smoke is coming out like this are an example of point source. So this is an example of point source. The second source of pollution is known as line source. The second source of pollution is known as line source. Okay. Now this is very interesting. When you ride a vehicle, right, you are constantly releasing the gases from the exhaust and simultaneously you are moving in a line. So all the motor vehicles are the example of line source of air pollution. All the vehicles will be moving in a line or in a curve, no problem. So while they are moving, they are constantly releasing this gases. So those are classified as the line source. So for example, this is my road. This is my road or a railway track, right? Or a air track, right? Whether it is a vehicle that is traveling over land or it is traveling over air. All they will release is like this. They will release pollution like this and they keep on moving in this direction, right? So this is classified as the line source. So all the vehicles releasing gases are the example of line source of air pollution. So the second source of air pollution is the line source. The third source of air pollution is known as area source. The third source of air pollution is known as area source. Now imagine there is one forest like this. There is one forest like this, and in this forest fire outbreak happened. In this entire forest fire outbreak happened. Now this entire area is burning heavily and releasing smoke like this and releasing gases like this. Entire forest is burning and it is releasing gases like this, right? Entire forest is burning and it is releasing gases like this. So this is an example of your area source of air pollution. This is an example of area source of air pollution. So burning forest is an example of area source of air pollution. burning forest is an example of area source of air pollution. Okay. So burning forest is an example of area source of air pollution. Okay. After this, when we are talking about pollutants, so basically, my dear, pollutants are of two types. Either they will be present in suspended form or they will be present in dissolved form. So next is treatment of air pollutants. Treatment of air pollutants. Treatment of air pollutants like this. Treatment of air pollutants. So pollutants are basically of two types. Either they will be present in dissolved form. Either they will be present in dissolved form or they will be present in suspended form. So there will be dissolved air pollutants. There will be either dissolved air pollutants or there will be either suspended air pollutants. Both these air pollutants have different technique for treatment. Suspended air pollutants. Either there will be dissolved air pollutants or there will be suspended air pollutants, right? So these air pollutants can be treated separately. If I want to remove dissolved air pollutants from the air, so I will go with the technique of absorption. I will go with the technique of adsorption. I will go with the technique of adsorption technique is used. What is adsorption technique? In adsorption technique, we basically take an absorbent like this. This is my absorbent, and over the surface of the absorbent, all the dissolved air pollutants are adsorbed. All the dissolved air pollutants are absorbed like this. Over the surface of the absorbent, all the dissolved air pollutants are absorbed like this. So this is my adsorbent. There is a huge list of number of absorbent, right? So based on the type of air pollutant, different types of adsorbents are used. So you take an adsorbent and over the surface of the adsorbent, all the dissolved air pollutants are adsorbed. All the dissolved air pollutants are adsorbed and this is removed from the system, and that is how you remove this dissolved air pollutants. This is how you remove these dissolved air pollutants. Okay. So these are adsorbed dissolved air pollutants. Okay. So this is the thing. Now talking about suspended air pollutants. So suspended air pollutants are present in suspension that we can actually see in the air. So these particles are either settled out from the medium, okay, by under the action of gravity they settle out from the medium, or they will be removed by obstruction, right? You provide some fabric filter where these particles are restricted. They are not allowed to move outside and they are removed from the system. So either these secondary suspended air pollutants are removed by gravity settling, or by restriction. They are removed either by gravity settling or by restriction. Okay. The different techniques that we use to remove these suspended air pollutants are, first one is known as gravitational settling chambers. Gravitational settling chambers. Then you have cyclonic separators. Cyclonic separators. Then you have electrostatic precipitators. Then you have fabric filters. Okay. Other techniques are also there. These are the main primary techniques that are basically used to remove these suspended air pollutants from the system. Okay. So this is how your dissolved and suspended air pollutants are removed. So you can have the basic idea. For removing these dissolved air pollutants, we need to go with the adsorption technique. And for removing the suspended air pollutants, you need to either settle them down under the action of gravity or you need to restrict them. In electrostatic precipitator, what we do is, there are two oppositely charged plates and in between that, we allow these air pollutants to move. So, due to the action of these charges, these pollutants will move towards the oppositely charged plates and they will get deposited over those plates from where they can be removed. Okay. So, this is how it is done. So, this is the treatment of air pollutant and this is how we do. Now, one simple concept to you is, usually in the examination, there comes a question to convert microgram per meter cube to ppm or ppm to microgram per meter cube. Usually there is a question that comes in the examination, right? This kind of question comes regarding unit conversion. So for unit conversion, you need to keep a check on 2-3 points first of all. So next topic of discussion is unit conversion. First of all, if we talk about liquids, okay. If we talk about liquids. So in liquids, the concentration of any substance is represented as milligram per liter. Concentration of any substance is written as milligram per liter and for this milligram per liter, we write it at ppm. We write this as ppm. But this is only for liquids. Now understand the reason why we can do it. When we talk about liquids, 1 liter of water approximately has a weight of 1 kg. 1 liter of water has approximately a weight of 1 kg. So when we are writing milligram per liter, when we are representing the concentration as milligram per liter, this is equal to milligram per kg of water because 1 liter of water weighs 1 kg. You convert this kg into milligram. You convert this kg into milligram. So you will find out this is 1 upon 10 raised to power 6 milligram per milligram. Okay. Now this 1 upon 10 raised to power 6 is nothing but ppm, parts per million. 1 part present in 1 million of the substrate. So in liquids, it is very easy to directly write milligram into ppm. Okay. But when we talk about air, we cannot directly write down this milligram into ppm because 1 liter of air will not weight 1 kg. So there we need to go with the alternate technique, right? So if I talk about air, in air, if I have to convert milligram per liter into ppm, there I cannot write directly. Reason is 1 liter of air does not equal to 1 kg of air. 1 liter of air does not equal to 1 kg of air. Okay, 1 liter of air is not equal to 1 kg of air. Now, how we will going to do this? How we can do it? Okay, so what we will going to do is to convert this milligram per liter into ppm. I need to convert milligram per liter into ppm. So what I will do is, say this concentration is x milligram per liter. So what I will going to do is, I will calculate the volume of x milligram of element in liters. And once I have the volume of x milligram of element in liters, I can very easily write down the concentration in ppm, because now the units will be liter per liter. If I anyhow calculate the volume of this x milligram of the substance, I can express this in liter per liter, and there I can write down as ppm. Okay. Now, how to calculate the volume of this x milligram of substance? So what you do is step 1, you calculate the number of moles. Step 1, calculate the number of moles. Calculate the number of moles. Calculate the number of moles of x milligram of element. Calculate the number of moles of x milligram of element. Once you know the number of moles of x milligram of element, you apply the ideal gas equation. Step 2, apply ideal gas equation to calculate volume. Apply ideal gas equation to calculate volume. To calculate volume of x milligram of element. So you can use this equation, PV is equal to nRT. This is my ideal gas equation. Here P is the pressure, V is the volume of n number of moles of the element. R is the universal gas constant and T is the temperature. So all these details will be provided to you. Only thing is, you need to substitute the number of moles and you need to calculate the volume. Pressure, universal gas constant, temperature, everything will be provided to you in the question. So this is my ideal gas equation. This is my ideal gas equation, and using this ideal gas equation, you can calculate the volume of x milligram of element. This is my ideal gas equation. So here P is the pressure. This will be given to you in the question. Then you have N. These are the number of moles. Of x milligram of element. Then you have R, universal gas constant. And T is the temperature. So this is how you need to proceed with these kind of questions, right? There is one more variety of question where opposite is asked, where you need to convert this ppm into milligram per liter. So in that case, what you need to do is, you will be knowing the volume, right? From the volume, you need to calculate the weight of that element. From the volume, you need to calculate the weight of the element. So I have just added one example here. So you can take this example and try to solve it. Here you need to convert this ppm into microgram per meter cube. Opposite. In this discussion, I have told you that you need to convert microgram per meter cube into ppm. Now you see this, how to do it. Second form of conversion. So air, now you need to convert ppm into microgram or milligram per liter. Okay. From milligram, you can write down microgram, no problem. So how to convert this ppm into microgram per liter? Okay. So what you need to do is, first of all, what is 1 ppm of air means? 1 ppm of air means 1 meter cube of element. 1 meter cube of element dissolved in 10 raised power 6 meter cube of air. 1 meter cube of element is dissolved in 10 raised power 6 meter cube of air. Now my purpose is to get the weight of this 1 meter cube of element. Anyhow, I want to get the weight of 1 meter cube of element. So calculate the weight of calculate the weight of 1 meter cube of element in milligram. Simple, right? Calculate the weight of 1 meter cube of this element in milligram. Now how to do this? Here we will going to use one fact, that is at STP, at standard temperature and pressure. What is standard temperature? Standard temperature is 273 Kelvin and standard pressure is 1 atmosphere. At STP, 1 mole of gas, 1 mole of any gas occupies 22.4 liters of volume. Occupies 22.4 liters of volume. Okay. Now you need to check in the question whether standard temperature pressure condition is given to you or not. If it is not given to you, then again what you can do, you can use the ideal gas equation. You can use the ideal gas equation like this. What you can do is, you can use the ideal gas equation like P1V1. So P1V1 upon T1 is equal to P2V2 upon T2. Okay. So this set of parameters will be for STP, standard temperature and pressure. Okay. So pressure will be 1 atmosphere, volume occupied by 1 liter, 1 mole of the gas is 22.4 liters and T1 is 273 Kelvin. And this P2, V2 and T2 will be for the existing situation. This is for existing situation. So from here you can calculate this V2. From here, calculate V2. From here, calculate V2, right? Now this V2 will tell us that in this existing situation, how much or 1 mole of gas is occupying how many liters of volume. In the existing situation, after calculating V2, what it will going to tell? This V2 will tell us, V2 tells us that at existing situation, 1 mole of gas will occupy 1 V2 liters of volume. 1 mole of gas will occupy V2 liters of volume. Now, knowing the volume in liters, you can calculate how much number of moles will be present in 1 meter cube of this. Knowing this, you can calculate how much number of moles will be present in 1 meter cube of element. Once you know this volume, once you know the number of moles, multiply it with the molecular weight to get the weight in milligram, right? Once you know this volume, right? So what you need to do is, after this step, next step is, so V2 liters of element occupies or has 1 mole. It means that 1 meter cube of element, 1 meter cube of element has 1 by V2 into 10 raised power 3 moles of substance, right? So from here you have calculated the moles of element. From these moles of element, you can calculate the weight of element. So weight of 1 meter cube of element, weight of 1 meter cube of element is equal to 1 upon V2 into 10 raised power 3 multiplied by the molecular weight of element. And please don't forget, this weight you will get in grams. This weight you will get in grams, right? Now you can substitute this weight and eventually you will have the concentration in gram per meter cube. That can be converted in microgram per meter cube or milligram per meter cube. So like that, you need to follow these steps. It's a very important question. You can try this question at your home, right? That's a homework question for you. Chalo. So by these words, I would just like to finish my session here itself. So these are some of the important basics which are required to read the air pollution. Okay. Just few quick announcements, my dear students. If you want to enjoy the regular quizzes, if you want to have regular job notification updates, you can join our Telegram group. The link is given in the description box. We at IMS Gate Academy, we offer you 4 different types of program: online program, offline program, hybrid program, and the self-learning program, where we are providing you with 800 hours of live teaching with interaction. We provide you with theory and exercise book containing more than 4,000 practice questions. We provide you with 12 personalized one-to-one mentoring sessions so that you have a proper guidance throughout your GATE preparation journey. We provide you with India's largest test series containing 130 plus tests, starting from the chapter test, subject test, multiple subject test, full length mock test along with the video solution. If you want to book a free counseling session, the link is given in the description box and you can call our senior education advisors. The numbers are provided here, so you can note down this number. So this is all what I have to offer today. Thank you so much for listening patiently. Have a great day ahead. Thank you so much.